Friends, welcome to our channel. In this video, we are going to look at today's daily challenge problem 1267. Count servers that communicate. So in this video, we are going to use dictionary to solve this problem. So here we are not going to pursue say O1 space solution, but we want to demonstrate to you the use of dictionary. So basically here we have a grid. So for the grid, if ij position has a 1, it means that there is a server there. So the servers in the same row and in a row or in a column, they will communicate. So here we want to return the number of servers that communicate with each other. So in the first example, so these two servers actually do not belong to same row or same column, so the total number of servers that communicate will be 0. So in the second example, so we have the rows and the columns connect all the 3, so the output is 3. In example 3, so the first row they have 2, and the third column they have 2, and this last one does not have the same row or same column servers, so the return for this one is 4. So this problem actually is rather straightforward logically, and also the problem size is not very large because m and by n is bounded above by 250 square, right? So here we can directly do the coding. So first I'm going to make some annotations here. What we are going to use is a dictionary, right? So what we want to do is that we find the servers in the same row and the same column, and then we just add to the result. So first, let me get the number of rows and number of columns. This is the number of rows, and this is the number of columns. So this is the routine, right? So next, I'm going to initialize two dictionaries. One is called rows. I'm going to use collections default dictionary. I'm going to use a default container set, right? So similarly for columns, collections default dict. So I'm also going to use a set. So this is going to store for each row index, let's say row, and then we are going to store the number of R and C's. So belong to this this row. Similarly here, we are going to store C, so a set of rows and C, right? And then we just need to check, so if its corresponding values have more than one element. If so, we just need to union those sets. So this is the preparation step. So now let's traverse the grid. I in range m for j in range n, right? Very standard. So now the rows I, so this is the dictionary, right? Then I'm going to add this position ig. So similarly, cos g, I'm going to add this ig, right? So here the reason I'm choosing to use set, it means I want to avoid repetition in counting. So this is the one major step. So now we have these rows and columns and up to date. Then let me initialize a result set. So this is a set, and then we are going to iterate over the values of the rows and columns. So for row set in rows values, right? So if the length of this row set is greater than 1, then all the servers in this row will communicate with each other, so we can add to the result set. So we will use result set, so union this row set, right? Then still, so the result will be called result set. So this is the one. And actually similarly we can do for column set. For column set in columns values, then similarly if call set the length is greater than 1, so result set will be union with column set. And then afterwards, because of the set, and also set here, so there's no repetition. We just need to return the length of result set. So that's the full code. Let me first run it. So run, let's see what's the problem. So here for ij, so I we add, so I guess I forgot a check. So if grid ij, right, equals 1, it means this position they has a server. So we're going to do this. Now let's check. Yeah, it passes all the 3 test cases. Now let's look at the generic case. Yeah, it passes all the cases. So now I guess it's it might be useful, so we can print out this information. So print out, so the rows, print out the columns, and then we can also print out here the result set. So now let's look at these 3 examples. So yeah, you see for this one, the first row actually they have one server at position here. The second row has a server at this position. So you can also check for columns. Then the result set is empty, so it's 0. So you can also check example 2, right? So this is the rows, this is the columns, right? Because this just has 1, you cannot add. But in the result, you should include this 2, and also you need to include this 2. But if you unit them, so they have 3 positions. That's the 3. So similarly, you can interpret this 4 servers. So in other words, if you use this result set, actually it contains all the communicating servers. So with that said, I guess that's about it for the current video. Thank you for watching.